Okay, so today we're going to start with geometry. We're going to talk about points, lines, and planes. So this lesson is very vocabulary heavy, but hopefully it's not so bad. If you like to draw, there's a lot of drawings in geometry, so that's great. Okay, so let's start. A point indicates location. So think about like when you're in a map and you like drop a pin for your location. A point has no size, right? So if I'm drawing right here for the picture, we have point A. You know, technically this point does have a size, right? Like I drew a circle, but in geometry, like technically that doesn't take any volume, right? You're just labeling a point, but it's not like the point has area. Okay, so a point is easy. A line is represented by a straight path that extends in two opposite directions without end and has no thickness. A line contains infinitely many points, right? So if I draw a line here, you could tell it's a line because it goes on forever. So that's what those arrows are. We're going to label point A and point B. We have a little cursive L. So if you think, right, infinitely many points on this line, even though I only labeled A and B, there's still like infinite points in between there. I didn't label them, but they exist, right? There's a point there and there and there and there and there and there and there, right? Okay, so when we are naming it, we have two options. We have option 1. We can use any 2 points on a line. So for example, we have AB or BA. Right? Either one works. It doesn't really matter the order because they're both going infinite in either direction. And then we have option 2. We can use a lowercase letter if it's already labeled or if we want to label it. Right? So this one was already labeled for us. This letter is usually cursive. So for this one we have line L, right? So that was given to us right there. So 2 options for a line. We can use the points or the cursive. This one's much more common. You'll most likely see the 2 points. All right, and then finally we have a plane. A plane is represented by a flat surface that extends without end and has no thickness. A plane contains infinitely many points. So think of, like, if you want to think of a plane visually, think of like a piece of paper. But this piece of paper goes on forever, right? So I'm going to draw this plane. If you see this plane, you know, it looks like it has ends, like it ends. But in actuality, this plane will keep going forever. We're just drawing it like this so you can see it in space, right? So if I have this plane, we're going to call this plane B, and it has a few points. It has R, S, U, and T, right? So this plane has 4 points that were labeled on it, but it has infinite points on it. And again, we have 2 options for naming. Option number 1, we can use any 3 points on the plane. And it doesn't really matter the order. So, for example, let's take R, U, and S. So we could say plane R, U, S. Or we could say plane, let's do T, S, U, right? There's a lot of different options. These are just 2. And then the second option number 2, is we can use a capital letter. So here they labeled it for us already. Plane B. So this one was already labeled for us. This one's probably gonna be more common actually, where they just give you the letter. Plane B is gonna be more common, but either of these work. And the reason why you need 3 points is because if I only had 2 points, then it would just be a line, right? If I only said R and U, it would just be this line. It wouldn't be the whole plane. But if I say RUS, now I know that I'm talking about the whole plane. Okay, now this is a little bit, sometimes it's hard to think in 3D, but let's do a practice drawing. So we're gonna draw 3D planes. So I'm gonna start with this parallelogram here. And then I have this long line here with the arrows at the top and the bottom. And then I'm gonna go to a different plane here, extend it back here, and then extend this one back here. So again, if you're bad at drawing 3D, that's okay. You can just look at the video, but if you like to draw, sometimes it's fun to draw these. So if we see here, this is 2 planes intersecting. We have this one plane, plane M, and then we have this plane here that I didn't shade in, plane Q. And I'm gonna label 2 points. We have point C and we have point D. Okay, so your task is to figure out what are the points, the lines, and the planes. So we have points, lines, and planes. Okay, so there's 2 different points. There's one line that can be written 2 ways, and there's 2 planes. So if you want to pause the video, you can try and get it on your own and then come back and check. Okay, so the points that we have are right here, C and D. The line, there's only one line that I labeled. It's CD. But you can also write it like DC. But remember to add the line on top. And make sure that there's arrows on either line. In another class, I forgot the arrows. I only wrote CD, and that was wrong. You need to have the arrows. And then planes, they didn't give us enough points, but they did just label it for us. So we have plane M, and we have plane Q. So hopefully from this drawing, you could distinguish the difference between points, lines, and planes. And we're going to go back to some more new vocab. So we have collinear points and coplanar, right? Sort of think of like co-worker, or if you listen to podcasts, like co-host, right? Okay, so collinear points are points that lie on the same line. So if we have a picture, we always love our pictures. We have our line, you could tell it's a line from the arrows, and we have 3 points, D, E, and G. So these are collinear points. They all lie on the same line, right? Let me give you a non-example, right? Non-example, right? If I had D, E, G, or let's do D, E, G, A, B, C, D, E, F, G, H, I, J, right? These are not collinear because they're not on the same line, right? I and H are on the same line, I and J are on the same line, J and H are on the same line, but they're not all on one line together. So these are not collinear, but these are collinear. And then coplanar, we have points and lines that lie on the same plane. Alright, so I'm going to draw my parallelogram again, my plane. But remember, it goes on infinitely. It's not just this little boundary. And we have, let's say we have 2 lines. We have a point C. On those 2 lines, we have point A, point B, right? So these are all coplanar, right? These lines and these points all live on the same plane. Okay, space. Definition of space. Set of all possible points. Okay, so just think of like outer space, right? There's like so many possible points in outer space. Okay, so we're going to look at this picture and we're going to try and answer these questions. What are 2 other ways to name QT? What are 2 other ways to name plane P? Name 3 collinear points. and name a point that is not coplanar with points R, S, and V. So again, if you want to pause the video, I'd recommend trying to do this on your own, just to test and see if you got it, and then you can check once you unpause the video. Okay, so what are two other ways to name QT? So QT is this line right here, right? We know that it's a line, but if you look further down here, we can see there's another point that's also on the line. So we could name TQ, we could name it QT, we could do TQ, we could just flip it. We could start to use N, we could use Q and N, or flip that one, N and Q. Or we could use T and N, so T, N, and N, T, right? So there's lots of options, more than just two, but as long as you had one of these two, you're good. Okay, what are two other ways to name plane P? So if we look at P, if we look at the way to name planes, right, we have two options. We have the capital letter, which they already did, and then we have any 3 points. So we need to use the points, right? So if we look on this plane, I can see R, Q, S, and V. So there's a lot of combinations. So let's just pick a few. So you could do plane R, S, V. You could do plane Q, V, S. Something tricky that I didn't mention is the answer that wouldn't work is RQS, because that is they're already collinear, and so you can't make a plane out of that. It's sort of tricky, but like imagine if I had this line right here, right? What if I had made a plane like right there? It would still have RQS, but it would be totally different from plane P. So we could do RSV, we could do QVS, we could do any sort of combination as long as it has a V. So it needs to have a V in there. Okay, a little tricky. Name 3 collinear points. Let me just put a note here. Needs to have V. Okay, name 3 collinear points. So we already know they need to be on the same line. So we could do RQS, or we could do TQN. And then name a point that is not coplanar with R, S, and V. So R, S, and V are on plane P, and the only 2 points that they gave us that were not coplanar is T up here and N down here. So T and then N. Okay, so those are all pretty good. I'd say the trickiest one was the second one, but hopefully you got it. All right, let's go to the next page. We only have one more page of notes. Halfway there. Okay, more vocab, like I said. A segment is part of a line that consists of 2 endpoints and all of the points in between them. Okay, so it's always helpful with a picture, right? A and B. Okay, so you always want to be able to differentiate between a segment and a line. So the segment ends, right? If you think about it like a podcast or like a show, like there's different segments, there's different parts, but they end. So the way that you would name it is that you would have A, B with a line over it, but no arrows, right? So we would not have A, B, right? Not that. It needs to just have a line without the arrows. Array is part of a line that consists of 1 endpoint and all of the points on the line in one direction. Okay, so array looks like a line in a segment, but it goes on in one direction. So you would label that A, B. So you name by the endpoint, but the endpoint must come first. So see how the A is the endpoint? It needs to be A, B. So it's not B, A. And then finally, we have opposite rays. Opposite rays are 2 rays that share an endpoint. they basically form a line. So we have A, B, C, right? So you can think of this as one ray going that way and one ray going that way, both starting from B. So if you were to name the rays, it would be BA and BC. So you'd have to make sure the B goes first because the B is the endpoint. So you couldn't do CB. It had to be BA and BC. So you want to be able to differentiate between these, right? So know the difference between a line, a segment, and a ray. Okay, let's look at this line right here. Name 3 line segments, name the 4 rays, and then which rays are opposite rays. So you can pause the video and try this out for yourself and then double check. Okay, so the 3 line segments are this little segment, and then both of those combined. So we have D, E, E, F, and D, F. Name the 4 rays. So we have this ray, this ray, this ray. We actually have a few rays. That ray, that ray, that ray. So there's actually 6. So we have, oh, but you can't label it from F. So we're gonna take out these. So those are the 4 rays. So we have EF, DF, ED, and FD. And then which rays are opposite rays, right? We have this E that can go either way. So we have ED and EF. All right, last section. Okay, so the word postulate is a new vocab word. It pretty much means like facts, right? We can't prove them to be true, but they are true. It's sort of like when you're arguing with your parent and they're like, well, I'm right because I'm your parent. The difference between postulate is like these actually are facts, these actually are true, but we're just not going to prove it. But these are just things that you need to know that are always true. Okay, so let's start with the pictures first because that's more fun, and then we will do the words. So we have A and B, a line. We have 2 lines. We have this picture already drawn for us, and then we have a plane with 3 points. Okay, so through any 2 points is exactly 1 line. Right? If I have any 2 points in existence, right, these 2 points, in between them is just 1 line, right? So these 2 points, there's just 1 line. If 2 lines intersect, they intersect in exactly 1 point. If 2 distinct planes intersect, they intersect in exactly, right? So we have this plane here, and we have this plane here. They intersect in exactly 1 line. In this example, this line is, looks like that's an S and a T. So this one's a bit trickier when you're trying to think of 3D, right? Like if I had 2 pieces of paper and they were intersecting, they would intersect like at that 1 line, right? So you just want to remember this postulate. If 2 distinct planes intersect, they intersect at exactly 1 line. And then through any 3 non-collinear points, there is exactly, what do you think, 1 plane. right? So remember on the back side when we're like, oh, it needs, right? When I was trying to find naming plane P, and we weren't allowed to do RQS. We couldn't do collinear ones. They had to be non-collinear. So right here is the postulate for it. Through any non-collinear points, there's exactly one plane, right? So if I take 3 points in anywhere in the world, they're gonna form one plane. Even if I have a point, you know, if I have a point above my head and then a point in my 2 hands, that would form one plane, right? Again, it takes a little bit to get used to the 3D, but I believe in you. You guys got it. Okay, last little problem. What is the intersection of plane QUE and plane EBT? So QUE is this plane right here, the bottom one. And then EBT is this vertical plane right here, right? So what is the intersection of that? Well, if we look back at our postulate, right? Well, I mean, you can pause the video and try and solve this, which I would recommend. Okay, so when 2 planes intersect, they intersect in exactly 1 line. So the intersection is going to be right here. We're going to call that line BE. Or EB, doesn't matter. Okay, and then one more bonus question that isn't on the sheet, but we're going to write down. Are points C, E, A, and T coplanar? So this one is really tricky, right? It's just a yes or no question, so you have a 50-50 shot if it was on a little check or assessment. But let's think. So we have C and E. We know those are on the same line, and we have A and T. So right off the bat, right? Are they coplanar? Well, the answer is yes, right? Even though they look like they're on different sides of this cube, if I was to connect all 4 of these points together, I'd get a new plane that is like diagonal, right? So even though they didn't draw the plane on this drawing, they still are coplanar because they together can be on the same plane. So the answer is yes. All right, so that is it for this first lesson. Very vocab heavy, but if you like to draw, start to think of things in 3D, hopefully you can start to see these lines, segments, rays, and planes.